for number one, the first thing that I'm going to do is I'm going to factor this thing. So I'm going to look and see first, always when I'm factoring, I check for a GCF. And I'm going to take out the GCF in the numerator because it is negative 3x. So I'm going to take out a negative 3x, and then this is going to become negative 3x times x squared minus 5x plus 4. Yeah. And then in the denominator, I have a GCF of x, so I'm going to pull an x out, and I'm going to have x times x squared minus 4, and then I'm going to factor further as much as I can. I'm going to end up with negative 3x times x minus 4 times x minus 1 all over x times x plus 2 times x minus 2. And then I'm going to see that, wait, wasn't there supposed to be something that canceled? Yes, there is. The x is going to cancel in the top and the bottom, and I'm going to be left with, and my simplified fraction is negative 3 times x minus 4 times x minus 1 all over x plus 2 times x minus 2. So because something canceled, I know there's a hole at where x is equal to 0, and then I just have to find what that hole would be. So I'm going to plug in 0 into this simplified version of my rational equation. So I'd have f of 0 would give me negative 3 times negative 4 times negative 1 all over 2 times negative 2. And that would be 12, negative 12 in the numerator and negative 4 in the denominator, which is equal to positive 3. So I would know that I had a hole at 0, 3. Because that's what the point would have been at x equals 0 had it not canceled out. I know that makes the denominator undefined, so that point is not going to be shaded on my graph. Then I'm going to do vertical asymptotes. I'm looking for, in the simplified version, what my x values are that are going to make the denominator equal to 0, and that's x equals 2 and x equals negative 2. So those are my two vertical asymptotes. For my domain, I know I have a hole at 0, 3, a vertical asymptote at x equals 2, and a vertical asymptote at x equals negative 2. So I know if I were to draw a little number line off to the side, I'd be like, well, I know negative 2, positive 2, and 3 are not included. So I'm going to put open circles on them. But then everything else is allowed. So I'm going to write this domain based off this little number line I created. I know I'm going from the first interval is negative infinity to negative 2, not included, so parentheses. Second interval is negative 2 to 2. Third interval is 2 to 3. And fourth interval is 3 to infinity. And none of those numbers are included because they were all holes or vertical asymptotes. That shouldn't be shaded on my graph for x. So that's my domain. Then I want to circle if this is a horizontal asymptote or an oblique asymptote. I know I compare the numerator power to the denominator power, or the highest power in the numerator and denominator, and they're the same, which means I have a horizontal asymptote, and that horizontal asymptote is going to be y equals a over b. So negative 3 over 1, which gives me negative 3, and that's describing the end behavior. So I know the limit as x goes to positive or negative infinity of f of x is equal to negative 3. And then for y-intercept, this would have been my y-intercept, except it's a hole. So I know that if I would have plugged x equals 0 into my original equation, I would have seen that there would have been 0 in the denominator. And I'm not allowed to have that, so that the y-intercept is undefined. This is the undefined y-intercept. And so I technically do not have a y-intercept. So I'm going to put none, and that's what you're going to put on your test if you see something like this. And then for zeros, that's my x-intercepts. I know those are when the numerator is equal to 0 in the simplified version of my equation. And so that's when x is 4. So 4 comma 0 is 1. And when x is 1, so 1 comma 0 is another. Then I'm going to put all this important information on my graph. So I have a hole at 0, 3 right here. Make sure it's an open circle on it. I have vertical asymptotes at 2 and negative 2. So here, oops. And negative 2. Terrible at dash lines. Then I have, I don't have to draw the domain. I just need to make sure I have how many pieces? I'm going to have 4 pieces. Just kidding. I'm going to have 3 pieces. 3 pieces, but a hole in one of them. And then horizontal asymptote is at negative 3. So here. And I'm just going to draw the horizontal asymptote for the end behavior on each side because I know I can go through it in the center. I could even go through it on the ends too. I just need to make sure that my end behavior, what's happening on the right, it's going towards this horizontal asymptote, and it's also going towards that horizontal asymptote on the left. Y-intercept is none, and then zeros are at 4 comma 0 and 1 comma 0, right? Okay. Yeah. All right. The only thing that I can do to connect, this one to this one is go like that. The only thing I can be doing from this important point to the right is I could be going down, approaching that vertical asymptote downwards, because I cannot turn around since this is not a special 0 that I saw the factor was repeated, so I shouldn't be bouncing off of it. Then from this hole, as I go to the left, I should be going up because I can't be going down because that would intersect with the x-axis, and I found all the x-intercepts and there wasn't one there. So I'm going up. That gives me the middle piece. Then I know the left piece, since this is not a special vertical asymptote, I know that when I approach the left piece, I should be approaching it upwards from the right since I was approaching it downwards from the left. And then I'll be approaching this horizontal asymptote as I go to the right. That would mean that the left piece is going to be down here because I should be approaching this vertical asymptote that is also not special downwards since I was approaching it upwards from the right. And then this is what my graph would look like.